Hello everyone, so in this video we will be discussing the confidence level of interval. So basically this is just connected with or related to the discussion that we had last time about the normal probability distribution. So unlike normal probability distribution, we can solve for, or we have to solve for, we can solve for the area and find the z-score. Here in the confidence level of interval, we have to solve for the area so that we can find the z-score. So we'll still be using the z-score table that we have from last time. So we'll be using that in order for us to find again the z-score of our problem. So here we have the formula. Z-score is equivalent to x bar. This is actually x bar, or the mean in sample, plus minus or plus the marginal error, where E again is marginal error, plus minus marginal error since we are looking for the interval. So meaning to say we have to find our lower limit and the upper limit. So here, marginal error is given by this formula, or this one. We have z of alpha over 2 times standard deviation over square root of number of sample that we have, or the n. Okay, where alpha here is equivalent to 1 minus the confidence level, or the CL, and subsequently CL is also equivalent to 1 minus the alpha. Okay, so we have to remember this equation so that we can solve for the marginal error, and after we have solved for the marginal error, we can already solve for our confidence interval. So again, we have here the table of our z-score, the positive and the negative table for our z-score. So let's try to solve some example under this one. So we have scores on an exam are normally distributed with a population standard deviation of 5.6. A random sample of 40 scores on the exam has a mean of 32. Estimate the population mean with 80% confidence. So from here, we have to determine what is our given. So again, standard deviation, that is denoted by the sigma sign or sigma symbol, that is 5.6. And number of scores or sample is our n, or that is 40, and our mean for the sample is 32. And it says here that our confidence level is 80%. So meaning to say our CL is equivalent to 80%, or just equivalent to 0.8. Now from that, we can already solve for our alpha. Since our alpha is 1 minus CL, or the confidence level, so basically that is 1 minus 0.8. And that gives us 0.2. So as we know, from the bell shape, we'll still be using bell shape here as our image or the figure. So if we try to draw that here in our bell shape for the area, we know that the center of this one, or you have to plot your confidence level in the center. So that gives us this center, the area of the center is 0.8. So if the center is 0.8 and the bell shape area is total of 1, meaning to say the remaining answer, or the remaining area, will be distributed equally by the two tails. We have the positive and the negative tails. So meaning to say alpha divided by 2, alpha over 2 is just equivalent to 0.1. Okay, so meaning to say our area here is 0.1, as well as here, that's 0.1. So again, this is now our area. So unlike again the normal probability distribution is we can solve for the z-score and find for the area, but here we can solve for the area and find our z-score. So if you can recall, the z-score is the basis of the z-score figure is among the left side, right? If you can recall that one, the z-score is from the left side of our bell shape. So that being said, we have to look at the negative table of our z-score. We have to find which area would give us z-score of this one. which area of 0.1 would give us a z-score. So from here, from the table of the negative side, we have to look for the area here, which is 0.1, the closest to 0.1. So in this case, we have here this one. We can have this as closer to 0.1. This is 0.1003. Since if this is our area, meaning to say our z-score is negative 1.28, right? And since by symmetry, our figure is symmetric, so meaning to say this is 1.28, the other one is positive 1.28. So meaning to say our z-score now is 1.28. Let's just drop the negative sign, so it's just fine. So we just have to use the absolute value of our z-score. So after we find our z-score, we can already solve for our marginal error, where in which this is equivalent to the z-score of alpha over 2 times the standard deviation over square root of our n. And as we know, z-score is of alpha divided by 2 is 0.1. That is again multiplied by the standard deviation. So the z-score of 0.1 is is 1.28. So that gives us 1.28 times our standard deviation, which is 5.6. So we have square root of 40 as our n. So meaning to say this is just equivalent to 1.13. But this is still the marginal error. We have to look for the interval again. We have to look for the interval. So in order for us to solve for the interval, as we know, CI or the interval is equivalent to X bar or the mean plus minus the marginal error. So let's say X bar minus E, that is mean, which is 32, minus our marginal error, which is 1.13. So that gives us 30.87. And for the other one, we have mean plus the marginal error. That is equivalent to 32 plus 1.13. That gives us 33.13. So meaning to say our confidence interval is 30.87 to 33.13. So this is now the confidence interval. And in order for us to read this one, we can read that as we are 80% confident that the interval of the mean is from 30.87 to 33.13. So this is now our answer. Okay, now let's try to solve for number 2, which is the 90% confidence. So let's have it here. So our CL is 0.9 or the 90% confidence. And drawing our figure, again we have, let's say this one. And this is our 0.9. Let's just redraw this one. So we have here, let's say this is our very perfect drawing. So we have 0.9 here as our area in the middle. So meaning to say what we have left on the sides are divided by 2. So that's alpha is equivalent to 1 minus 0.9. That gives us 0.1, and that is still divided by 2 because we have 2 tails. So that would give us 0.05. So meaning to say the area on this side is 0.05 and this one is 0.05. Now, again, this is just the area. So we have to look at the area, the z-score from the table. So here we're still basing that from the negative z-score table, 0.05. So we have to look here at the closest one. So as you can see, we have here the closest 0.05 and 0.495. They are the most closest values or areas for 0.5. So we can have the z-score as average. So negative 1.64 and 1.65. So let's just average that one. So our z-score is an average of 1.64 plus 1.65 divided by 2, because we are looking for the average, so you have to divide that by 2. So that gives us 1.645. So meaning to say this one is negative 1.645. This one as well is positive 1.645. Okay, and after that we can already solve for our marginal error. So we have 1.645 times our standard deviation of 5.6 all over square root of 40. After that, this is equivalent to 1.46. So we already got the marginal error. We can already solve for our confidence interval, which is plus minus of marginal error. So we have x minus marginal error. That gives us 32 minus 1.46, which is equivalent to 30.54. And the other one is 32 plus 1.46, that is 33.46. So our confidence interval now is 30.54 to 33.46. So meaning to say we are 90% confident that our interval is 30.54 to 33.46. Okay, so now we'll try to solve for the number 3, which is the 98% confidence interval or confidence level. So we have here, again, the same given, but we have our confidence level as 0.98, or that's 98%. And again, our standard deviation is 5.6. Our mean is 32 and our n is 40. So from that, we can solve for the area. So we have 1 minus our CL, which is 0.98, and that gives us 0.02. And if we try to draw the figure again, we can have this. If this is our 0.98 in the middle, so meaning to say 0.02 will be distributed by the two tails that we have here. So we'll divide it by 2. So meaning to say we have 0.01 as our area for the sides in our figure. So we have this 0.01. So from the table, we have to locate again which z-score would give us a 0.01 area. So we have here 0.01. So which among here is the closest? So we'll have this 0.102 and 0.099. So that gives us the z-score of 2.32 and 2.33. So let's just average that one. So we have our z-score is 2.32 plus 2.33. Let's just have this in absolute value since we are just using the positive z-score naman. So that is now equivalent to 2 point, I'm sorry, that's 2.33. So if our z-score is 2.33, we can already solve for our marginal error, which is 2.33 times standard deviation of 5.6 divided by square root of 40. So that gives us 2.06 as the marginal error. So after we have got the marginal error, we can already solve for our confidence interval. So again, that is given by the mean plus minus the marginal error. So for the lower limit, we have mean minus marginal error, which is 32 minus 2.06. And for the upper limit, we have the 32 plus marginal error. So that's 32 plus 2.06. So this is 29.94. The other one is 34.06. So that being said, our confidence interval is from 29.94 to 34.06. So this is now our confidence interval. So if you can observe, the more the confidence level is big, or the level goes bigger, our intervals also gets wider and our marginal error also gets bigger. So as you can see from here, our marginal error is just 1.13 in 80% confidence, 1.46 in 90% confidence, and when it comes to 98% confidence, our marginal error becomes bigger, which is 2.06. Okay, so let's try another example. We have here, compute a 99% confidence interval for the mean weight of the Valencia oranges with a sample of size 25. So that is given by n is equal to 25, our mean is 10, and our standard deviation is 2. So from here, again, our confidence level is 0.99. Now we can solve for the area, so that gives us the alpha. 1 minus 0.99, which is basically equivalent to 0.01. Now again, that is divided into 2 because of the segregation or the division of the two areas that we have. So that is 0.005. So in this case, if we try to draw the figure again, we have, if this is our 0.99 area here, meaning to say the sides, the area of the sides is 0.005, and as well as here. So from the area that we have, we can already find for the z-score from our table. So again, the z-score here, 0.005. We have to find which is the most closest one. So we have 0051 and 0049. So that is under 2.57 and 2.58 z-score. So let's just average that one. So we have 2.57 plus 2.58 divided by 2. That is just basically equivalent to 2.575. So that is now our z-score. Meaning to say this z-score here is negative 2.575. The other one is positive 2.575. So we can solve for our marginal error. So we have 2.575 times our standard deviation, which is 2, divided by our sample space or sample size, we have 25. So basically that gives us 1.03 as our marginal error. Now again, we are going to solve for the CI, or the confidence interval. So that is equivalent to x plus minus marginal error. So we have, for the lower limit, we have 10 minus 1.03. The other one is plus marginal error. So we have 10 plus 1.03. So 10 minus 1.03, that is 8.97. And the other one is 11.03. Now, meaning to say our confidence interval is 8.97 until 11.03. So this is now the answer for our problem in 99% confidence level. Okay, so I hope the discussion is clear on how to get the confidence interval. Now I'll be giving you your activity, which is you have to answer this one. Okay, basically that's it for our discussion for this video. Thank you everyone, and I'll see you on the next sessions.